I'd like to go through the intro to this chain rule lesson just to make sure that everybody kind of understands some of the notation here. Sometimes it can look a little confusing, but it's really not as bad as you might think. So, what we're doing now is we're going to be taking the derivative of composite functions. So that would be something like this. If you had f of x is equal to the square root of 2x squared plus 3, then you can think of this in a different way. You could think about this as being made up of two functions. So you could say f of x is really some outside function and then having some inside function. So you can think of this as being f of 2x squared plus 3, where the 2x squared plus 3 could be like your g of x. That's like its own function, right? So like the outside function here would be the square root of x, and the inside function would be 2x squared plus 3. Okay, so that's a bit of a review for composite functions from last year. And, sorry, I kind of got ahead of myself. So what we're going to do in Math 31, typically we use the variable u to represent that inside function. So you could say f of x is really going to be f of u, which we know is 2x squared plus 3, which would be the square root of u, or the square root of 2x plus 3. And you might be saying, yeah, so what, right? But this u is going to show up in our equation below. So let's go down. So here's our rule. It says for any composite function, we can use the following rule. So let's see if we can make sense of this. So if f of x, so some function, can be written as a composite function, like the example above, then the derivative of that function would be this. It would be f prime of g of x. So like the derivative with that 2 in the one above, 2x squared plus 3, as like our input function. Okay, it'll make a bit more sense, and let's just show some examples like what's happening there, but like how that would actually look. And then the derivative of the inside function, just the derivative on its own, right? So that is the chain rule, and I'll show you how that can work in practice. It's actually handy. This one's actually nicer, I think, than using quotient rule and product rule, if it just for ease. But now the way the chain rule is typically written, though, the way that you'll probably see it written more common, is like this. So it'd be if y is equal to f of u, again, just saying can be written as some composite function, where u is just some other function, is all that's saying. And then I just like to break down what this is saying. This is saying dy dx. So that's just saying like another way of saying the derivative of y, right? Then the derivative of y is equal to dy du. So that was like this part. That's saying the derivative of the function with the inside function as like the input. And du dx. So that was actually this part. That's like the derivative of g with respect to x. Now I keep saying like with respect to, and you're probably not that used to it, but so what does that really mean? So yeah, when we have this written, no, it's really, this is saying like the derivative of y with respect to x. So that's like saying the derivative of y when x is your input, right? That's like that's like this. That's like saying like when I have f of x, that's the input right there. Okay. Now this one, dy du. So that's this. That's saying the derivative of y, but now u is my input, right? Because that is u. Oh, that was a weird way, right? U. That is my u. And then the derivative of u with respect to x, well, that's this, because u is g. So it says g prime of x. Yeah, so now x is my input. All right, I do promise that this will make more sense when we're actually doing it. So then, yeah, I kind of wrote that out on this one as well. Okay, so now let's take a look at this warm-up. You can just look through it if you want, but it might be nice if I just kind of relate what we just talked about above there. So now, if we take the function that we were just looking at, and then rewrite this as y is equal to 2x squared plus 3 to the power of a half instead of the square root. And now let's call the inside function u. So this is going to be just considered u. So the function is going to become y is equal to u to the 1/2. Okay. So now take the derivative of this function using u. So just pretend instead of an x, just take it with u instead. And then multiply it by the derivative of the inside function. Okay. So looking at this, right? So the derivative of u to the half, so bringing down the 1/2 would be 1/2 and then u to the power of -1/2. And from our equation above, that is dy du. Right? That's the derivative of y now with respect to u instead of x. On the next one, du dx, well, that's just the derivative of the inside function. That's the derivative of this guy on the inside, which would just be 4x, right? Bring the 2 down, so now we got 4x. Simplifying this up a bit, scroll down a bit, we have 1 over 2 and then square root in the bottom, right? That's just getting rid of the negative and then turning it back into a square root. And then just the very last step here, we would just replace u with what we know it is, 2x squared plus 3. Okay, so in this case, right, you can see like in red here, we're just going to replace the u with that function and then just brought the 4x up to the numerator and then simplified the denominator, and then that would be our final answer. And you might be saying the denominator should be rationalized, and yeah, you'd be correct, but probably good enough for now. But yeah, you're right. We could rationalize the denominator, and that probably would be an even better answer.